Hi guys, welcome to this page of the notes, and what we're going to do here with the next several example problems that I have for you is we're going to continue with this theme of rewriting an exponential as a radical or a radical as an exponential expression. But now I'm going to go a little bit further and have you evaluate these as well. This is going to get you a little bit of practice, both using evaluating the ones that you can evaluate. If it's a cubed or a square, where you probably have most of those memorized, or if it's something bigger than that, a little bit of practice using your calculator to evaluate these kinds of expressions. So let's just jump right into these next couple example problems and see how they're going to look. So again, I want you to rewrite each expression, rewrite each one, then go ahead and evaluate it. Well, the first one I've given you is 16 to the negative 1/4. Well, the first thing I need to do, right, is I have a negative exponent, and that's no bueno. So we're going to take it to the bottom and rewrite it as a positive exponent. So the first thing I'm going to do is rewrite this as 1 over 16 to the 1/4 power. 1 over 16 to the 1/4 power. When I take the whole thing to the denominator, the sign of the power changes. It goes from being a negative 1/4 to now a positive 1/4. And then, of course, the last thing I'll do is I know that 1/4, whatever the denominator is, becomes the index of the radical. So this will be 1 over the 4th root of 16. Well, in order to evaluate this guy, right, this is now, I've rewritten it as a radical expression. I want to evaluate it. And what I'm looking for down here, right, the 4th root of 16, which again, you absolutely can do on your calculator, but I think you probably are familiar with this one. You're looking for a number that if you raise it to the 4th power, gets you 16, which of course would be a 2. So the 4th root of 16 is 2. But it's in the denominator, so I would have 1 over 2, and evaluating this guy would be 1/2, right? So this whole thing evaluates out to a 1/2. The next one. I have 243 to the 2/5 power. Well, we've talked about this. In order to rewrite it, the numerator remains the exponent, so it would be 243, which would be squared. I put it in parentheses to what I don't want you to make the mistake of doing. You don't have to put the parentheses in there. The only reason I put the 243 in parentheses is for this reason. If I just wrote 243 and then squared, some kids might accidentally think that it is just the 3 that's being squared, right? And I don't want you to make that mistake. So again, you don't have to write the parentheses, but I like to put the 243 in parentheses so that you don't make the mistake of thinking it's just the 3 that's squared. It's the whole number 243 that's squared. As long as you don't make that mistake or don't get confused, you can leave the parentheses out. And then we know the denominator of my rational exponent, my fraction, becomes the index. So I'm going to be taking the 5th root of that guy. And again, the way that I would do this on my calculator, so that my calculator, again, your calculator is going to do whatever you tell it to do, but a lot of kids sometimes tell your calculator to do the wrong thing, and that's not your calculator's fault. You're just not familiar enough with your calculator and how to use parentheses properly, so here's what I would do. If I were you, on my calculator, I would do 243, and I'd square it, get whatever that's equal to. Then, if you have the TI-84 graphing calculator, on the far left-hand side of your calculator, there's a button that says Math on it. You'll go into the math function, and I believe it'll be the 4th or the 5th option in that list that'll allow you to put in a radical where you get to tell the calculator which index you want, right? So you'll make that index a 5 because you're taking a 5th root, and then you take the 5th root of whatever 243 squared was, and again, if you do all of that, you're going to wind up with a 9. So the 5th root of 243 squared is going to be 9. Double check that, use your calculator, make sure that you get a 9. If you don't, you'll want to, again, go through your user manual, check to see exactly how the nth degree radical function works on your calculator. Make sure you get that down. You definitely want to get a 9 there. So anyway, next one. All right, I've got 27 to the negative 1/3 power. So again, one thing I got to do before I can rewrite this guy is, my first step in rewriting this guy is going to be to make that exponent positive. So that means it all goes to the bottom. So 1 over 27, which will now be to the positive 1/3 power. And then, of course, I know because my denominator is a 3, it'll be a cubed root. So 1 over the cubed root of 27. All right, well, now we want to evaluate this, but actually this one's pretty easy. This should be one that you guys are familiar with. The cubed root of 27 would be a number that when it is cubed gets me 27. Well, that of course would be a 3, right? 3 cubed is 27. So this whole guy down here, the cubed root of 27 is a 3. It's 1 over that. So when I evaluate it, I would get 1/3. And the last one I got for you here on this page, 64 to the 2/3. Well, the 2 stays an exponent, so it'll be 64 squared. Again, I just put it in parentheses so we don't make the mistake of thinking it is just the 4 that is squared. It's the whole number, the 64 squared. And the 3 becomes the index of my radical. And again, you would use your calculator to evaluate this because I'm sure you don't have 64 squared memorized. That's okay. And even if you did have 64 squared memorized, it's highly unlikely you know what the cubed root of that number is. So anyway, you do all that and you should wind up, you do that all in your calculator, you should get a 16. I got a couple more for you on the next page. Let's jump over here to this page. The exact same thing. I want you to rewrite each expression. Then we will evaluate that expression. Of course, using our calculator in most cases will be the way you want to do this. So I have a 27 to the 2/3. Well, let's rewrite that. That'll be a 27 squared, and I'll be taking a cubed root of that. And once again, highly unlikely that you know what 27 squared is. And certainly if you did know what 27 squared is, you wouldn't know what the cubed root of that number is. So this is definitely something I would encourage you to use your calculator for. And if you use your calculator correctly, you should wind up with a 9. I get 9 again. 9. And then the last one I got here. Okay, so this is awesome. Check this out. Before, when the exponent was negative, we couldn't have a negative exponent, so we took the whole thing to the bottom. In this case, it's not the exponent that's negative, right? The base is negative. That's okay. The way this is going to work is the numerator stays the exponent, the denominator becomes the index, and what I'm going to do then is rewrite this as a negative 16 cubed, but then I'm going to take the square root of that, right? Because my denominator was a 2, that means I'm taking the square root of a negative 16 cubed. Now, an interesting thing happens here. First of all, highly unlikely that any of you know what negative 16 cubed is, and that's okay, you have a calculator. But here's what you do know. You do know that anytime you have a negative number raised to an odd power, the result will be negative. Negative 16 cubed is going to be a negative number. But then I'm asking you to take the square root of it. Well, you can't take the square root of a negative. Sorry, I apologize. When you take the square root of a negative, this isn't Algebra 1. I got Algebra 1 brained on you there for a second. Thought we call square roots of negative numbers undefined. But this is Algebra 2. You do know what to do with the square root of a negative number. It's imaginary, right? We now know, let me just write it down for you real quick. I is equal to the square root of negative 1, right? This is our definition of imaginary numbers. Anytime take the square root of negative 1, we call it I. Well, that's exactly what's going to happen here. I'm going to wind up with a negative number underneath this square root symbol. And in fact, actually, I don't even need to write the 2. We could just write it as the 2 is implied. So anytime you take the square root of a negative number, you're going to wind up with an imaginary number. So you put all that into your calculator, and your calculator will probably freak out at you. That's okay. Just remove the negative, right? And so you would rewrite it like this. We're going to have the square root of 16 to the 3rd times the square root of a negative 1, which we know is I. So on your calculator, you'll do 16 cubed, take the square root of whatever that number is, and then I know the square root of a negative 1, which I pull out, is I. So you do all that on your calculator and you wind up with 64I. Okay guys, what that does is that takes care of this, this first objective or learning target for this set of videos, which was rewriting rational exponents as radicals, and then vice versa, rewriting radicals as rational exponents. So hopefully that makes a lot of sense. Hopefully you've gotten a little bit of practice using your calculator. You know how to use it correctly to evaluate some of the more complicated ones. Head over to the next page of the notes and we'll start taking a look at simplifying these rational exponential functions. So I'll meet you guys over there.